Tonight, he reports on Brown's gas.
Well, put your thinking caps on, because for most of us, the technical reasons why Brown's gas works are mighty complicated to understand. So we're going to break it down a little bit. Brown's gas begins with water, ends with water. Pretty simple. When it produces a flame, it does so not through explosions like fossil fuel, but through implosions. And here's a definition for a word you'll tossed around. When something is sublimated, in this case, it means it's being directly changed from a solid to a gas. So here goes.
What the professor has done is taking ordinary tap water, separated it into two atomic components, hydrogen and oxygen, and now we have a clean burning fuel that's renewable and reusable, and when you burn it, it goes right back to water. This is a piece of pure tungsten steel, 100% pure tungsten steel, and it takes 6,000 degrees centigrade, close to 5960 to sublimate, which would take approximately 10 times more than what it takes to weld aluminum. Without any adjustment of this flame, I'm holding my finger there, we can sublimate tungsten steel instantly, go right back to gas.
Brown's fuel is also different because the temperature of its flame varies depending on what it's burning. The scientists to say the flame temperature is due to an interactive combustion property.
The heat is produced by the material. The tougher the material, the hotter the flame gets or the reaction is.
So what does all this mean? What exactly could Brown's fuel actually do for us?
In the future, with this technology, we will be able to run cars and power plants with clean burning water as a fuel source. And since the Earth is covered with 2/3 water, we will no longer have an energy crisis in this country or in the world, and we'll clean up the environment in the process.
Using this process, we're talking about a very, very small amount of energy. Professor, could you come over here for a minute? And we don't know because of the lack of data and research that's been done. But let me ask you a question. If we took 1 liter of water and applied 1 kilowatt of electrical energy to that liter of water, it would create 340 liters of gas. No? What would it create?
1 liter of water and 5 kilowatt of electrical energy.
Yes.
So give me 1,860 liters of gas.
1,960. 1,860 liters of gas. Okay. Now that gas, if exploded with oxygen a little bit at a time, using 5 kilowatts of energy, it could it push how much water, how high?
I don't know. I didn't explode. I couldn't tell it. I didn't rate this.
Okay.
According to explosion, according how much air you put inside.
Without exploding it then, using just the implosion process, we know that we can draw it up 1 atmosphere or 10 meters through the implosion, and then in turn, because of the pressure which is being generated just from the creation of the gas by itself, we can push it up another what, 30? Another 30 meters beyond that. So just the implosion and pressure, we can put that up, and that would be about 40 meters for
an implosion.
So the cost there is just a few watts. 5 watts. 5 kilowatts to move
1 liter of water. Okay. 1,960 liters of water.
1,960 liters of water up 40 meters. Approximately. Okay. And then if you ignited the gas, blast it in there. Okay. Very good.
How about this? When this case okay, melting the house grade. There is a temperature here that should be about 2,500 Celsius. And that's an instant thing. Now, this flame creating a different temperature for different elements. If I take an aluminium, this flame is also formed, produced from water, and when it's burned, producing back the water. You can see dripping the water. that show that life is non-polluted. But now the most important thing, what's very definite now, that this flame could burn himself and doesn't give it any blisters or any mark or any complication whatsoever. It's not like any other flame which is burning, is coming a big, blisters and so on. With the camera here.
It is. I don't believe
and this hot flame, which is called the brick, I put in my hand.
Yes. Jesus.
So you can see that's a deep burning. Burning on this part here.
Yeah, I see.
So that's a 35-degree burning. For such a thing, burning is all another ordinary flame. You have to go to the hospital and take it days and days to cure it, that will come into big blisters. But that flame never will give it blisters. It's given to this mark, which tomorrow the mark will completely disappear. And I let you to see it tomorrow.
All right, we'll tape it tomorrow.
All right, to tape it this again to show. Now, why I do that? To show that with this flame, we can use it in the operation table.
Oh, for surgery.
For surgery, instead of laser beam, it's not controllable. So
Instead of what?
laser beam.
Laser beams, which is not controllable.
Controllable like this flame is.
Uh-huh. Okay.
All right. So that's the first thing. How good is this flame and how reacting on the different element entirely different. Now let's see. I have here aluminum.
Aluminum, yes.
Aluminum. Where's the price? Yeah. That's the price. So first thing, I take it from it.
Go ahead, Gus. What is this, Gus?
Aluminium welding flux.
Aluminum welding flux. They speak funny in Australia. They can't help it.
Yeah. That's true. Good. Very funny. And I take it. You can watch that I'm not a welder. I try sometimes to do good welding. I do good welding by life. But he's a welder. He's a specialist to do perfect welding. And this is running like silver. You can see it. Nice. We got even on this side that is penetrating very, very good. That is the posture, you see the penetration of this. Now, we need only to stretch the surface. Coming close.
I am.
Or small implosions. So that not any radiation is going around.
Uh-huh.
And you can see it if I hold at the nozzle just here. Take it very, very close. You see, it's about 2-3 millimeter. I hold the vest directly to the neck. And I just take it, a piece of brick. And I apply this folding. It's so close. You never could do this with any other flame. This flame is extremely high concentration. Still I got it. Jesus. I wish somebody to do this experiment with oxy-hydrogen touch.
600 degrees centigrade.
So yeah, approximately. I will put this tungsten rod. Tungsten rod, which melting about 3,600.
Let me zoom in on that one so again right there. Okay. Tungsten electrodes. Okay.
Right. So this tungsten electrode is melting point 3,900 degrees.
3,900
Celsius. And sublimate.
Sublimate meaning it turns into
On the
vapor.
On the vapor.
Okay.
And sublimate on the 5,960 degrees.
It sublimates at 5,960 degrees Celsius.
Yeah. And now, the same line without I was adjusted. Melting the aluminum and weld aluminum at 600 degrees.
Yes.
I will apply it to tungsten, and you will notice the tungsten instantly sublimate. Instantly sublimate on the 6,000 degree. That is something what you couldn't do with another flame. Maybe you can do it trick with the oxy-hydrogen, then introducing much more oxygen, then you don't sublimate the tungsten.
But I noticed that we only have
just oxidating
yeah,
the
but we only have one tube going to that particular unit there. I
That's
understand.
perfect sublimated picture. Right, one more. This one. That's refractory brick. It's about 4,500 degrees.
4,500 degrees it takes to sublimate it?
No sublimation to the melt. Yeah.
Go ahead.
To the melt. Okay, now. We'll see what is the reaction of that. Extremely dry.
Again, the sound you hear in the background is that of the unit changing DC to AC. Brown, and we're at his first research lab facility that he has operated here, what, Professor, for the last 20 years? Last 20 years. And in this particular area within the lab facility, why don't you explain what we have here, Professor?
What we have here is a gas generator, which I built it. It's a utility gas generator which producing hydrogen and oxygen mixture. From this gas generator, we have a power supply, with a lot of instrumentation, which I follow how much kilowatt is going to my gas generator. Then, from this gas generator, we supply gas for this motor, which is modified with special gas.
Now the modification was a LPG modification?
That was taken bias and modified, specially modified for the hydrogen and oxygen. And this gas is taken a long time modification. But this motor is connected with the dynamometer.
A dynamometer, yeah.
Which dynamometer is measured the brake horsepower.
The brake horsepower.
That's right. The idea was how many kilowatt electrical energy is got there, how much gas producing, how much brake horsepower producing in diameter, and how much water, because the exhaust, that's it, the exhaust here, is coming to the condenser. This condenser have the coil, on which coil is run water. That's two different connected to what's condenser. I come in here, which I measure how much water is there. So I know the amount of the water, I know the amount of the electrical energy, I know the amount of the gas, hydrogen, oxygen, I know the brake horsepower, and I'm making what is the efficiency. Because by the field, when you're adjusting the motor, maybe you can create excessive heat. I was calculated a special electronic device, and this electronic device is connected to the shaft. From here is coming to the electronic board, so that's one here, and from the board controlling this fan, which give it
It's a fan which gives it the equivalent of the speed that the car would be running at, the wind going through there, so you get a better handle on what the cooling capabilities are.
Right, so that I know exactly. That's most work was done here. The whole equipment was installed. The room was making special for the motor dynamometer, gas vibration, and special power supply was designed and built.
Now what is this up here, this krypton triangle?
That's a tuning up for the motor.
A tune-up system for the motor. Okay. And what kind of motor is this motor here?
That's a Holden.
A Holden. Which is is that a Ford or product?
No, Holden.
Just a Holden. That's a 6-cylinder there?
That's 6-cylinder motor.
All right. Okay. Motor. Could you explain a little bit about how the motor worked? Generally, it's like a regular motor, except that the gas that was created went in and imploded, thus pulling up the piston.
No. It's an ordinary explosion. It's
Ordinary explosive.
Nothing to do with the implosion. The implosion motor I didn't want to introduce it now, and I want to introduce till I see that people accept it. If they don't accept this, the first step, how I can put in the second step.
Okay.
So that's the idea why I stopped it.
Now, was there any possibility for this motor to blow up in the event of an accident?
No.
Generally, can you explain why? It's a regular spark.
Regular sparking.
Uh-huh.
Now I can increase the power, and I can increase more. I can increase more.
What's the purpose of that?
More. It's a big purpose because the different mixture of the hydrogen is near to different spark, and that is.
What happened? Why didn't the research continue on this?
Because lack of funds.
Lack of funds.
Lack of funds.
And was the government here helpful?
No.
Not at all.
Definitely not, because the government here is let you to doing your job, your research. If you make the money, they are partners. They take good tax. Why they should help you? You find somebody else to help you. But they are third partners all the time.
Uh-huh. Now you put this, and you did explain to me the engine the other engine that you had running in a vehicle.
Oh, yes.
And what was the reason why that vehicle was not allowed to continue to operate on the road?
It's not completely finished. That was only demonstration unit. Making a short distance with the bottle of the hydrogen. And I'm talking 20 years back. So when the people was know very little about the hydrogen car, hydrogen energy. I was pioneering on that. So, of course, it was very primitive to coming on road to the market, it wasn't finished. Then I passed into the very best time that was an investment, and everybody tried to pull down. The company doesn't like it, the gas generator, they have 20 bottles gas to sell. Arabs have plenty of the oil to sell. Who wants the gas generator after for 20 years? Nobody at all. And everybody wanted just something to pour in the car and liquid. That's not the gas. That's the reason why LPG gas doesn't become very popular here.
Yull, I've got a question for you. We've got this complete facility here. You have this motor, which you can probably be up and operational with, or another one like it, to prove that the concept works like you did previously in a couple of months. Because of all the other things that are going on right now, it'll probably take that long. As I understand, this motor has, or this type of concept for this motor has numerous particular uses.
Sure.
You have also other whole different technologies which could be used for boats in the water, for trains, things of this nature. And the whole concept is that it takes a tremendous amount of money for research that you are curtailed through numerous break-ins, through, for whatever reason, and for lack of money for research to continue your efforts in this particular vein. You saw while you were, I'm repeating all this so that everyone will know, while you were working on this, you realized that you could take the gas and use the gas as the flame to be a welding device, and you saw that as a means to make a profit to get in. That's why you're producing welding machines and cutting machines.
Not to hydrogen machine, it's directly from the water. But when the money is finished and generator was on, I think it out to making more money. So I had to put a welding torch and coming a welder and try to sell the welder to raise the money to come back to the motor.
I understand.
So my intention is not a welder. I don't like it that heavy to making this right.
Okay, very good. We've got this handled.